So what have I done here? I've picked one of the loop invariants, namely the very first one, the one where a top left has been overwritten with the result, but the other parts have been left alone. And notice that the constraint is that L top left times U top left is equal to the original contents. Now, finding the loop guard, not so difficult, right? Inherently we're going to go from top left to bottom right. You've seen that before, you're used to that. Finding the initialization step, again, not a big deal. Partition A, L, and U such that the top left part is empty and the loop invariant is inherently true. So that's good too. The loop invariant we've already picked. How to repartition? Well, we need to make progress towards completion, and therefore at the top of the loop we repartition exposed, another row and another column, and then at the bottom of the loop we would move the line ahead. You've seen that before as well. So all of that is good. The real question becomes, what is the state of these exposed pieces after we do this repartitioning? And how do we do that? We take the loop invariant, we do a textual substitution of the pieces fitting them in. By now hopefully you've recognized that as sort of splitting the range, except for two-dimensional arrays. And then we manipulate, right? So let's see what happens if we do that. Well, actually, why don't you go and try to figure it out? So, come up with the state of the different pieces of the matrix in step 6. Okay, let's have a look and see how that works. Well, we do what we always do, right? We replace A top left with A00, 0. We recognize that A bottom left now becomes A10, A20. Then we get an A01 here, an alpha 11, A21. So far so good. Now, A00 has been overwritten with L and U 00. But the rest of the parts have been left alone. And L00 times U00 is equal to A00 hat. Very straightforward. So why don't you next come up with step 7, the state after the update.